Hello and welcome to our lesson on crystallization. By the end of this lesson, you should be able to explain how crystallization works. I've got two questions for you. Why do intrusive igneous rocks form bigger crystals? Why is the appearance of these blue copper sulfate samples different? You can pause the lesson and resume when you're done answering the questions. Now, you can see in both cases, the rate of cooling affected the crystal size. So, bigger crystals because this took longer to cool down as it is formed on the ground. This was allowed to evaporate more slowly. This was heated until the solute was completely dry. That means all the water had evaporated. We take advantage of this method in crystallization technique, which you will understand a bit more later. Now, how does crystallization work? Take a look at something here. A solution contains dissolved substances called solute. If you heat a solution, the solvent or the liquid evaporates, leaving the solute behind. This is not different from evaporation, which we covered in previous lesson. Now, this separation technique is called crystallization. If you use too much heat, you end up with a powder. Sometimes you can even change the nature of the chemicals within the product. But if you give the solvent time to evaporate slowly, probably naturally, by leaving it by the window, you give the crystals more time to form together in an ordered pattern. How does crystallization work? So how do we use this method in the lab? Crystallization is used to separate soluble solid from the liquid that is dissolved in. So something that is soluble in a liquid, so that is a solution, not too different from evaporation. Now, you evaporate solvent, leaving the solid to cool. So you can use heat, it can happen naturally, to get rid of the liquid, which is the solvent, and allow the solid to cool and form crystals. Now, the difference in this case and evaporation is you give the crystals, the solution, plenty of time to cool down. So because as the solution cools, the solute becomes less soluble and the crystals start to appear. But if you leave it to cool naturally or heat gently, the crystals form together in an ordered pattern. So you have bigger crystals with regular, clear to see pattern. That's why in the lab, with evaporation, you can heat the evaporating basin directly, and what you end up with is get powder. But if you use a water bath, what you do is you put boiling water, you put water in here. As the water is boiling, the heat from the water heats what you are evaporating gently. This means the particles stick together and form regular crystals. That's the difference between crystallization and evaporation. You use gentle heat. You allow it to happen over a long period of time. You can even do it without heating. Remember, evaporation can happen at room temperature. It is just that it takes longer for crystals to form if you leave it to happen or evaporate naturally. Whereas applying heat to reduce the amount of solute to a point and taking the heat off when you start to see the crystals appearing gives the crystal time to form regular pattern. Thank you very much. With crystallization, you can clean up the product or the crystals and go over the process again.